Hello, my name is Adolfo Herrera, and this is my video for the Lab 3 project. I did the part 2 of the project, which was a 2D sim on a cylinder. In this case, it'll be a circle because it's a 2D simulation. Here you can see the circle. It is and you can see the setup as well. For the geometry, we recycled the wind tunnel from Lab 1. Then this is sort of the setup on the workbench on ANSYS. This is the mesh setup. You can see the imported surface body. We have a element size of 2.5 times 10 to the negative 3 meters. So we have a pretty fine cell around the cylinder since we're not doing any prism layers. And here you can see, you could see it on the other window as well. The inlet, outlet, and cylinder are named so that it is easier to determine with what inlet and outlet boundary conditions we're dealing with. We're going to do 200 number of iterations for the simulation. Here you can see the models. I have it in laminar because I just did the viscous flow analysis. I'm going to change it to inviscid for this one. Next up, we're going to go to the boundary conditions and set the inlet velocity to the corresponding value for 60 hertz from Lab 1, which is 12.55 meters per second. And afterwards, I am going to show that the reference value for the velocity is 0, so that we have an increasing velocity throughout the simulation. And then we're just going to go to the initialization window to initialize the sim. It had initialized when I opened it, so wait here, 30 iterations. That'll do. It's a pretty simple sim. And then we're going to run it. Here you can see the boundary conditions visually. They are not very visible from afar because of the mesh. Then we're going to run it 200 iterations. We could do more for more stable results, but it is a pretty simple sim. As you can see, the residuals are pretty stable. They could be lower, but again, that's just because of just a few iterations that we're running just for the sake of time. Now, after running the sim, we can visualize our results by going to graphics and doing contours. In this case, I'm just going to do the velocity one because it's the sort of main focus of the experiment solutions shown in the report between inviscid and viscous flow. Here we can see it throughout the whole wind tunnel. We're not selecting the cylinder because it's not actually shaped. It's just a section that is not area, and it's not an area of the wind tunnel. And you can see there's not a boundary layer developed in neither the cylinder or any of the walls in the wind tunnel. Obviously, because we're doing inviscid flow. If we're doing laminar or turbulent flows, a boundary layer would develop and we would see it. And then you can further demonstrate this by showing the velocity, plot of the velocity throughout the curvature of the cylinder, which is not 0 because there's no boundary layer. If we were doing laminar again or turbulent, we would have 0 velocity across the area, or not the area, but the entire curvature of the cylinder, because a boundary layer would have developed. And so yeah, that is it for this video for the report. Thank you.